everyone. This morning, a guy arrived here at the location with a huge bag, an ice hockey bag. I was thinking, hey, holy moly, are you going to play ice hockey? But now Max is going to discover what he's going to bring with the ice hockey bag. Stage is yours. Thanks, Max.
All right, mic is on. Great. So hello, everyone. I think everyone here in the room, the audience is perfect for this, has dealt with DevOps, DevSecOps, BizDevSecOps, and whatsoever, has built 2 pizza teams, or all these things. But if I ask everyone here in the room, what is it really? I would probably get as many different answers. And I believe it's different for another ops, namely GitOps. And there it is. Welcome to the talk, how to never go shopping groceries again, or how to explain GitOps to your manager. And I'm Max. I'm a senior solution architect at Red Hat. And the only important thing to know about me actually today is that I have a big family. That also leads me to my first question. Who in the room has already kids? Please raise your hand. Oh, that's a lot. Wow. And now even more hands should go up, because who in the room has to share the kitchen with another person? So great. I hope most of you, or hope everyone, can relate to the story I want to begin my talk with, which basically goes like, or which basically is about a typical weekly shopping trip in my family. How this usually works is that my wife sends us off with a well-prepared shopping list to the supermarket. Here you can see me with 2 of my kids, 5 and 6 years old, heading to the supermarket. And, well, we try to stick to this shopping list, but as you can see on this picture here, some things get in between, especially when we go through the candy aisle. But at the end of the day, we arrive safely home with 3 to 4 big shopping bags, and we stuff everything into the fridge. So good. That's fine. At first, everything seems to be fine, but usually in the process of using the fridge, we discover problems. And I want to point out just a few. First thing is that I forgot something that was on the list. Last time it was Iowa. You needed to make spicy pasta. I never heard it before, so I simply forgot about it. Second thing is, and again, pointing to this picture here, more stuff than intended ends up at home. It regularly happens, especially if my spouse is also going shopping, but we didn't talk to each other, and we have everything twice. All right. And then the third thing is that, often when you pick something in a supermarket, especially when it comes to fruits and vegetables, something is already moldy. So it is basically, even when you pick it, it is you don't want to eat it anymore. And then I don't notice it because we have so much stuff, and we put it in the fridge either way. And then the fourth thing I want to point out is, picture a very tasty item in your fridge, and maybe a chocolate topping. You need to make a cake for next grandma visit. With in our household 6 people, chances are high when I want to make the cake, it's not there anymore because someone ate it already. And the last thing, this picture is not a clear depiction of our fridge, but often it is really full. It's boasting. There's so much stuff in there, so it's just full. So there are 5 regular challenges I thought about, can we solve them? And after all, in IT we did, I think. And how did we? Well, I want to make a proposal here. It's the GitOps fridge. And there it is. This is version 1. Many thanks to my kids for borrowing it to me. And so the first thing you need when you want to do GitOps is, of course, a cluster. This is our representation of the cluster. But more importantly, you need Git, right? You need GitLab, code.siemens.energy, code.siemens.com, sorry. You need GitHub. You need all these kinds of things to make GitOps work. And now the most important thing, and give a big round of applause for the one doing the magic today, Rito, you know him already. Please come up to the stage. He will take over. He's gonna take over. He's doing the GitOps magic today. So let's start. Let's point out the features of this GitOps fridge one by one, right? And the cool thing about GitOps is, if we move to the first one, fill the fridge right, you don't have to go shopping groceries anymore. They just come to you at home. The only thing you have to do is You have to declare it. You don't even have to put the stuff into your fridge, into the fridge yourself. Here is what this could look like. And the only thing I'm going to do is I put it here, and I also put it there. Rito comes into play, has a look at it, fills the fridge, and I hope it worked out. It's filled. We see 3 bottles of milk. We see 2 chocolate bars. And importantly, look at those. There are 2 tomatoes, pointing it out for a reason. All right, let's close this again. Okay, now I also have to send some prayers to the demo guard because I want to take it to the cluster, of course. And if we move over to the command line, we will move to the command line in a second. At first, I want to show you, here is the Git repo. It's public, so under my account. So we have a Git repo. The document I've just showed you, it's basically here. Here are our fridge items. I can look into one of them where we see the 2 tomatoes. There are 2 tomatoes here. And we also have a cluster. This is a Kubernetes cluster. It's OpenShift. This is the namespace view of the top of the fridge compartment now. Basically, we have only one compartment right now, so that's it. So the only thing we need to do now is we need ArgoCD, open source project. Many of you probably know it. This is doing the GitOps magic today. And no, there should be nothing there, exactly. It's empty. Only thing we need to do now is head over to the CLI and create an ArgoCD application. And the first one looks like this. We have a source. That's the source. It's a Git repo. We have a destination. That's the fridge. And now the only thing we need to do is we need to apply is, or we can use, I don't want to confuse you, we can use kubectl, which you're probably used to, and we can run kubectl apply 00a, and then we apply this to the cluster. Wait a minute, we'll appear here. Now, the Rito magic is happening again. Why is it gone? It did vanish again. But here it is. You can see the fridge is filled. We have 2 packs of tomatoes. So you can see there are 2 pods here on the very right. And yeah, the fridge. Let me see, Wi-Fi was a problem before today. It doesn't. The only thing you would see now is a filled fridge. It doesn't load now. I don't know why. Either way, the first thing we have solved. I cannot forget things anymore because whenever they're on the list, they will end up in the fridge. But what if the shopping list lacked stuff? So if my spouse actually forgot something, it is very, very easy. You just need to run an update. There it is. And you need to put it into the Git repo. You need to bring something. You have it? Great. Of course, we also have to provide, now I'm introducing 2 new terms. This is the desired state. Over here, we have the actual state. So we have the 2 YAML files in both places. Not enough space here. But now, voila, we can see there are 3 tomatoes in the fridge. Yeah, and if we take this to the cluster again, what you would usually go through now is you would go to the folder where you have declared all the items that you want to have in all the parts of your application, and you would raise this to 3. You would run a git add, git commit, git push, and ArgoCD would automatically pick up the changes. For the demo purposes, I will keep it a little bit simpler. I have made a customized overlay already, which is doing the same thing for us. So if I run now again kubectl apply -f00b, we should soon see that those, maybe I should really switch to my mobile network, but as soon as this is created, we would see an increase of the replicas of those pack of tomatoes to 3. Let me quickly disconnect from where's my mobile phone? Oh yeah. Now it's configured. I'm connected to my mobile network now. Great, so what we should see now is, if we refresh this really quick to check whether the internet is working. Damn, always the internet, right? That's a pity, it's not working anymore. Let me turn on the Wi-Fi again. Do you believe it? All right. There are no 3 pods. Great, it did work. Awesome. So let's tackle the next problem. The potentially moldy things. And you can do several things about it, I guess, but the easiest that came to my mind is let's at least separate it from the rest of the stuff. And that's what we will be doing now. So I have, again, a declaration for that. So here you see, again, kind fridge items, fruits, oranges, 5 replicas. So we want 5 oranges. And we want to put it in the potentially moldy compartment. And I put it here. Rito, come here. We have to put it here, so we have to declare the actual state in the cluster. Yeah, higher. Yeah, like this. Yes, and there you go. Now the fridge has 2 compartments. We can even turn on the lights, but I don't know why those toys always have to make noise. So I will keep turning them off again. Great, that did also work, and I hope my internet is back now. Because what we can do now is, we can do the same thing. I have again, some YAML files that make up my application in that case, and I can point an ArgoCD application, which I called the rotten oranges. I can point an ArgoCD application to the source repo, and the destination is again my cluster, and I can add something to the sync policy, namely that it creates an own namespace, so that this part of the application is isolated. And if we apply that, kubectl apply -f 01, yeah. We should now see, if we head over to the cluster, that there is a namespace which is called potentially moldy, and if I'm lucky, then we see that we have the rotten orange here. All right, so that's also working. And I don't know why my ArgoCD is leaving me in the rain today and is not displaying the applications, even though it seems to work, otherwise there wouldn't be anything in the cluster. But let's move on. Because we have also solved that issue. Now, what about the little thieves that ate my chocolate topping? And that is, again, very easy. So what do you think? And now everyone will hopefully know the answer because I introduced desired and actual state. What is going to happen if I pick this tasty chocolate bar, close the fridge? What do you think will happen? Yeah? He would throw it in. Yes, exactly. And the same thing is what ArgoCD does. Let's check if we are in the right namespace, in the right Kubernetes namespace here. No, we are not, so we have to top of the fridge. We go to the namespace called top of the fridge. And again, it's very fast, but maybe I can also show it in the UI. Top of the fridge. All right, and if we say in OpenShift, we can just do this in the UI, we take out some chocolate bars. What do you think is going to happen? Of course, it is scaling up now. It is scaling up again. Great, thank you very much, cluster. Again, and the same thing works the other way around, of course. If I scale up to 3 or 4 or even 5 pods, it is working against me. It keeps pushing it down to 2. So that's what ArgoCD is doing here for us. And we got the 4th topic solved. Now, if that would really work with my fridge at home, I would probably have a big problem because we regularly would have snack attacks at home. And not only the kids, I guess, but maybe also the bigger ones. And let's move to the next step, which is called little and big thieves. And what we are going to do now is we again declare something. And now we move somewhat away from applications or food that is in our fridge and to configuration. We configure the access of our fridge. And again, we can do this via YAML. You see here 2 access types. One is full fridge access. Obviously, the parents need full fridge access, of course. Right. And then there's limited access for the kids and also for the little thieves. I'm not saying that they are always the same, but You get it. Okay, and that one we are not putting into the same repository. Of course, we are putting this into a different repository. I named it security because we are talking about authentication here. And now we also declare an actual state, and Rito has again a job to do. Yeah, put the lock on. And if we take this to the cluster again, and we go to a folder called fingerweg, all of the Germans now know what that means. The others we'll see in a minute. What you can do is you can also configure in Kubernetes and OpenShift in that regard an OAuth identity provider here. It could be sign in with Google, sign in with what you want. What I just did here is I configured an HTPasswd identity provider. And to manage everything via YAML, I used a sealed secret to encrypt the HTPasswd file. So that gives me the option to do everything with GitOps. And if I do this again, I have, of course, an ArgoCD application, which points to this folder again. And then I run kubectl apply. And then we have 02. We apply it. And what you will see now, it is saying it is unchanged. And that's because I did it before. Because it takes 3 minutes until the OAuth pods get restarted and are actually picking up on the change. But the effect you can observe either way. So, I mean, I'm logged in as a kube admin. And if we think about it, everyone is logged into the fridge at home as a kube admin. Is that a good idea? I don't know. But what we see here now is the identity provider we have configured via GitOps, and it's called fridge users. And if I log into that as a little thief, yeah, we only have access, unfortunately, to the potentially moldy compartment of the fridge. Of course, if I log in as that, you would guess what happens then. I'm not going to do it now. Okay, so that's also solved. So we are almost at the end. There's still plenty of time left. That's great. What if it's full? Maybe I can ask the audience, what could we do when something is full? What are the options? I have 3 in mind. Maybe you give me a 4th one. Anyone? What can you do about the fridge when it's full? Eat something? Oh, that's the 4th one. I didn't have that in mind, actually.
Buy a second fridge.
Buy a second fridge. That's also possible. That's something I will come back at the end of my presentation to.
Potentially multi-department.
Yeah. So what I had in mind is, of course, we could also compress things, but maybe for tomatoes and things like that, it's a bad idea. So we are not going to do that. The second thing I had in mind was, how about putting stuff that doesn't necessarily have to be in there? I mean, I like my chocolate from the fridge. Maybe someone else does not. We could also put stuff out of the fridge. And what I brought for that problem is I brought a bucket. And it is not only a real bucket, it is also a bucket. Here, is it visible? It is also an AWS bucket, and what we could do it, and we could put in the chocolate bar here. And now you might wonder, what does it have to do? Oh, and I forgot something. No, I didn't. What does it have to do with GitOps? Let's take it again to the cluster to figure it out. There is another folder here. It's called Get Stuff Out. And what you can see here is a YAML declaration of an S3 bucket. This is very, very simple, but the important thing to notice, and I can increase the size a little bit, should have done it in the beginning already, sorry for that. It is calling a Kubernetes API called s3.services, blah, blah, blah. So what we did is we created a custom API with AWS controllers. This is called to be able to manage also resources outside of our Kubernetes and OpenShift cluster inside of AWS. And while this is a very, very simple example, I also added a somewhat more complex one, which is an RDS instance, in that case Postgres. And what this does is it creates a basic Postgres database in AWS. And again, I use the sealed secret concept to provide my Postgres passwords and things like that. And again, I have a ArgoCD application, which points to the folder I've just shown you, and as a destination to the cluster. What is noticeable here is there's a particular namespace in the cluster. It's called ACK system. And that's the namespace where the controller is basically monitoring the resources to create in AWS. And we are doing this, kubectl apply. That was the name 03A. And we wait for it. It got created. This is good. Now I have to log. Oh, I don't have to log. Actually, I shouldn't have to log into the cluster. Now I hope this also works. You see here my S3 buckets. There are two. If you remember the name of the bucket I have just shown you, the bucket was moving from KA to AWS. And if I refresh, if I'm in luck and everything's fine, we will see the moving from KAs to AWS bucket here. And the same thing should be true for the RDS database. You see right now there's none. If I refresh, we should see an RDS database being in the creating state. Awesome. So why is that cool? I mean, many of you are working with AWS or Azure or Google or whichever cloud. And some are using some have their own infrastructure as code tools. Some use Terraform, some use Ansible. I think it's pretty cool if one of the key components of your architecture is Kubernetes and OpenShift or OpenShift, and you manage most of your resources via YAMLs. Because then you don't have to open another stream for managing the resources outside of your cluster. All right. Great. That was its full option one. Now the final is we got to increase the fridge or the size of the fridge. And for that, we have, again, a declaration. It looks like this. Should also be here in the slides. Yeah, you remember top of the fridge. It's already there. You remember the potentially moldy compartment. And now we are adding one. It's called a freezer, and it's going to the bottom of the fridge. Guido, stage is yours. I help him now. There we go. The fridge is increased. Actual state has to be appended, of course. There it is. Okay, so now I ask you again, what do you think am I going to do to my cluster now? Any guesses? All right, I will show you. Let's go to the final 3B, just enlarge it. And what I put in here is something called a machine set. In Kubernetes and also OpenShift, nodes are managed via machine sets. So we have the concept of machine sets owning machines and machines owning nodes in the cluster. And if I head over to the cluster for a minute and I log in again now as the kube admin to have access to, oh my gosh, now I have to log. Yeah, please autofill. I have to log into the cluster, and I want to show you the compute that powers this Kubernetes cluster here. And I go to the administrator view for that, and we have a compute section here, and we see the three concepts I've just explained. We have the machine sets, and this one is running on AWS, so it's running across 3 zones. Just in 2 zones, I have spun up worker nodes. We have 6 machines here, 5 machines here, so 3 masters, 2 worker nodes. Very, very simple cluster. And that's our current setup. But as we've just figured out, it's too small because it's already full. So let's increase it. And we can increase it by just creating a new machine set. And the important information from this machine set is its kind, and then again the replicas. So now it's 1 replica. So if I'm applying this to the cluster, how many additional worker nodes we get? 1. But we could also scale it up. Okay, let's clear this. kubectl apply f03b, and then we wait for a moment. And immediately, if we look to the machine sets, we should observe a machine set which is called bulk my fridge. It hasn't been there before, and it has 0 out of 1 machines. This is because, of course, this doesn't go in seconds, because we now have to spin up a new EC2 instance for the cluster, roll out the kubelet and all the Kubernetes stuff that it needs to run and become part of our cluster. And we see here it is provisioning. And if I would head over to my EC2 console now in AWS, we would already see that a virtual machine is being spun up. And I could easily increase it like that. And what we see here is that GitOps goes way beyond just configuring your applications. You can really use it for configuring security, for configuring your cluster with everything that is defined in YAML. Okay, so we are through with the GitOps fridge. Everything is solved. That's my proposal. I think Siemens is also producing fridges, so maybe you can reroute the presentation. But to wrap it up, what I just said, the power of Kubernetes is really that everything is declared via YAML, and you can make use of that with GitOps and benefit from having everything in your version control. Here's a contrib also so with the new logo of GitLab, which I just learned in the break that there is a new one. And you can make use of it, and you get 3 big advantages. First thing is everything goes through version control. So everything you do, it is in here, any change is monitored. Second thing is you have a single source of truth, because again, everything is in the Git repo. And the third thing is, whenever someone meddles with the resources in the cluster here on this level, as you have seen, it gets remediated by ArgoCD as long as you don't change it here. All right, so what's up for next time? Someone proposed already. We should bring some more fridges to show how great GitOps works with multi-fridge management. And what I would also love to do is, of course, I would like to show you how we upgrade all via YAML the version 1 GitOps fridge to the version 2 GitOps fridge. And yeah, having said that, the only thing that's left for this presentation is we should configure the fridge right for later tonight. And having said that, thank you very much for your attention. And thanks, Rico. Any questions?
How many clusters do you use day by day?
One is running on my laptop. One is running in AWS. We have a lab in Munich. Depends. Most of the time, more than one.
So I would maybe get your opinion on, or an overview of the different GitOps approaches that are there, because you showed ArgoCD, and there's other ones. So, or the other strengths that you find in ArgoCD versus the other ones. If you had to choose one in your project, which one? Probably Argo, I guess. But your view on this?
Yeah, sure. Frankly speaking, I'm very much biased because the only GitOps tool that I have used and also brought into production is ArgoCD. So I cannot tell you about how is it better than Flux or the tools that are built into the source control vendor tools. But I think what is really differentiating, and I didn't want to focus too much on ArgoCD today, but ArgoCD is of course heavily backed by Red Hat. We have, as you have seen, we have even included it. Just as Rito explained earlier, there is something called OpenShift serverless. We have something called OpenShift GitOps, which under the hood is ArgoCD. So we are heavily supporting that. And I think the concept is beautiful. When it comes to ArgoCD, there are a lot of features. There's a big community. There are many users out there. And I think that's the biggest strength of ArgoCD. It's adoption and its community. And that it can actually drive very, very many features you especially need, because the first part was really that one here. It was about applications. But now we move into things such as cluster configurations, and that works a little different. For instance, the latest feature, and the only reason why I could show you how I configured the identity provider is something called server-side apply, where you can actually merge things into resources that already exist, which is a nice feature again. Probably not the answer you expected, but I didn't want to say what is better in one or the other GitOps tools, because frankly speaking, I work with ArgoCD most of the time.
Maybe as a follow-up, what don't you like, or things that are like itches for you in ArgoCD, or that you would like that they improve?
Let me think about it. I just don't want to outright say it's perfect. No, I'm just joking. We'll have to think about it. I mean, there is a big roadmap, but it all goes into features such as the one I've just explained. It's something that has been on the roadmap now. It's there, so the scope of GitOps with ArgoCD grows again, right?
Yeah, thanks for the great presentation. Sticking with the terminology, what would be your proposal to have something like a dev, a stage, and a prod fridge, and maybe a feature branch fridge that you can create automatically or something?
Oh my God, that's like in German we would say the Gretchenfrage in DevOps, so I'm really reluctant to give an answer here. Because so we are working, of course, with a lot of different companies at Red Hat, so we see a lot of different approaches, and I think it is not so much about how many fridges you have, it's about organizational concept you have woven around it. And if this works for you, maybe it is 4 clusters. Maybe it is, hey, we have 2 clusters and we separate the stages in dev and stage maybe in 1 cluster, and prod and QA or production, close to production testing, we put it into the other cluster. I mean, there are a lot of options. And I think it depends on the application, also the non-functional requirements you actually have to capture and you have to test. But let's follow up on this, happy to do so.
Just asking, how is the state managed? I didn't really get it. Like, is it really a YAML which is somewhere in the Git, or how is the state?
Yeah, exactly. So the state is always...
So it's not like...
It's always here. So you have seen, for instance, if we just recap on that one here.
So you don't have like Terraform has, for example, somewhere
the state is here. That's
okay.
the state.
So okay.
That's the desired state. And then we have, Rito played that role today. We have someone looking to this and to this. And as soon as something changes on either side, it is getting set back to the state that is declared here.
Oh, so it's the Google approach.
The state is always in Git.
Okay. Right.
And that is really that is the whole idea of GitOps. Everything goes through Git. Thank you.
Thank you.
Thank you so much.
Can you make it clear for me the difference between, or what you think is different, GitOps and DevOps and so on, like to distinguish this, or is it all the same? Because some parts sound similar.
Thank you very much for the question. So that because initially I claimed that I want to give you an analogy so that everyone explains GitOps in the same way after this talk. This will never be true for DevOps, because DevOps can be how do we do CI/CD, as I said, how are we doing the developer teams, how are we establishing a new culture in our company, how are we building a new silo, which is called DevOps, but is not working together with DevOps. So GitOps is really a very well-defined process. It is saying desired state goes into Git and is being applied to one or multiple instances. GitOps is not limited to Kubernetes. You can do GitOps with other tools in ArgoCD. You can do it with virtual machines. You can do it with whatever you want. I've proposed one way today, of course. But GitOps is a very specific process. DevOps is a concept that has grown and is too big to capture, I would say.
Thank you.
I have another question. The YAML files you use to create RDS DB on AWS, there's still kind of alpha API or something I've seen there. How production ready is that part?
Well, for this presentation, and it's, where is it? It's here. So, as you said, this is pretty fresh. So we have tested this in the first projects. There's also another open source project, since we are on the open source days, and I see also Siemens projects playing around with this, that there's also something else around. It's called Crossplane, which serves the same purpose. It creates new, let me go to that one here. It creates new API endpoints in Kubernetes to do the Terraform or CloudFormation job, actually, but just by declaring it in YAML. And as you see, this is pretty new, so it's an alpha. And we are exploring now how So we are testing it actually, but there are some customers already using it. But this is from AWS, so I cannot tell you all of what's behind the roadmap. And what they observe, it's out on operatorhub.io. It's also integrated into the OpenShift operator catalog, where you can test it, and then there are other projects which are basically employing the same concept. And Crossplane is around for a while already. I think 4 years or 5.
No. Cool, thanks. More questions?
Okay, first of all, thank you for the presentation. You mentioned some minutes ago CloudFormation. It's only CloudFormation that you support, or even Terraform could be supported?
Oh, well, thank you for the question. So this is completely independent of CloudFormation, even though it might be that under the hood, AWS, as soon as it reaches an API. So what is happening here is we deploy this YAML file to the Kubernetes cluster. It will initiate an API call to AWS, and what AWS then does to spin up the resources is up to AWS, but you are not touching CloudFormation, you are not touching Terraform. This is really an alternative approach.
Okay. Thank you.
Then I would say thank you very, very much, Max, for this awesome presentation.